If you're making a linear platformer, then this video might be very helpful for you. We will create a camera system that follows your player using waypoints. Waypoints for your camera can be very useful in certain situations. It allows you to showcase the environment and build atmosphere on the player screen. So let's assume your player movement is ready, including moving left, right and jumping. The only thing that is left is the camera. Of course you could use StateMachine or code your own camera follow, but that's not what the video is about. So let's create a script, call it camera control. Open it up and remove the start and update functions. What we need is the position of our player and the camera component. So serialize field transform target and serialize field camera. To make it better structured in the inspector, I'm going to use a header here. The next thing we need is a camera smooth value to smooth out the camera movements. So serialize field float smooth time. We're also going to need some waypoints, which are vector2 values. For waypoints, we're going to create a new class because we will expand it later on and access it from the class. So public class camera setting, public vector2 position. And to see it in the inspector, you just have to add system.serialize field on top of that. Now go up and type in header waypoints. Again, that's only for the structure in the inspector. Serialize field list camera setting path points equals new list camera setting. Okay. We also need two private variables here, which are private int current point index, that's the current waypoint index, and the private vector3 velocity, and set it to vector3.0. That's the value for smoothing out the camera movement. For smooth camera movement, we are going to use the late update, which is going to call right after the update. In here we check if we have more than 0 path points and our target exists. If that's true, then we store our target's position in a vector2 target position. Right after that, we create a new integer, new index, and set it to the current point index. Now let's check if our player is close to a waypoint in our list. Create a new float to store the closest distance in. So float closest distance equals float.maxValue. And in a simple for loop, we get the vector2 distance for our target position to the current index of our path points.position. So basically from our player to the current path points position. If the distance is smaller than the closest distance, we set closest distance to distance and new index to I. Okay, so now we need to check if our new index has changed to tell the camera to move towards the new waypoint. So if new index is not current point index, and if that's true, then we need to make sure that the index has changed by ±1. And if that's true, then we update our current index. Down below we calculate the target position of our camera based on the current index. But before doing that, we need to create a function which calculates our Y position, because otherwise we'll be stuck on the same Y position when the player changes its Y position. So if the player jumps down, we're going to be stuck on the same Y position with our camera. And to avoid that, we need to recalculate our Y position. So create a new function named private float calculate Y position int index. And now you can just copy this function right here. What it does is pretty simple. It interpolates the Y position of our camera between the waypoints. So basically moves the camera from the current position to the next one based on the player's position. If there aren't enough waypoints, it just returns the camera current Y position or the Y position of our last waypoint. Now let's get back to our calculation right here. In here we need to create a vector3 camera target position, where the x is our target.position.x, so the player's x position, and the y is the value that gets returned from the calculate y position. And the parameter is our current point index, and the z-axis is just the camera.transform.position, because we don't want to touch the z-axis of our camera. Now we just need to update the camera position, so let's say camera.transform.position equals vector3.smoothDamp. And in the brackets, we want to change the vector from camera.transform.position to camera target position. We also need to reference the velocity and set the speed or time, which is our smooth time. To actually show what the waypoints are, we need to use the gizmos function. You can just copy the code right here that I'm showing. It just simply combines all the waypoints and shows that on your screen. Alright, so let's jump back into Unity and create a new game object in your hierarchy. Call it camera settings and drag in the script you just created. Now in the inspector, you need to reference the player and the camera. And now we can start to create our first waypoints. Just simply click on the plus icon and adjust the value. It's actually better to start with 2 points to see the waypath. If you don't see the gizmos here, it's probably because you've disabled that. Make sure to toggle the gizmos icon here in the scene view to actually see all the gizmos in your scene. Alright, and also make sure to set the smooth time to 0.1 or even higher if you want so. And now let's press play. So as we expected, the camera is following our player on the camera path. Looks good. One more thing that I'd like to add is the size or zoom of the camera based on the current waypoint. So every waypoint can have its own camera size. To do that, open up the script and on the header settings, create a new serialize field, float, size, change speed. That's just to speed how fast the size of your camera is gonna change. Go to the camera setting class and add public float size. Now in late update, right below the camera transform, you add camera.autographic size and lerp it from the current size to the current waypoint.size. And the speed is time.delta time multiplied by size change speed. Alright, let's get back into Unity. As we can see, we have expanded our class in the inspector. If we start the game now without changing any value, we will not be able to see any difference here. Now let's increase the size change speed a bit, and we see our cameras changing its size. It's zooming in basically. It's because our current waypoint is 0, and the current size of the waypoint is 0 as well. So let's stop the game and adjust some values in the inspector. So once you've done this, start the game and see what happens. Alright, looking good. I hope you were able to take something away from this video, and if you have any questions, feel free to let me know in the comments down below.